How did you do? Were you able to get the acceleration to be negative 10 meters per second squared? You find yourself on these questions sometimes going, you got to just really focus to make sure you don't go the wrong direction. You might want to integrate here, and sometimes you're integrating, sometimes you're doing the derivative. So you just have to focus on that. Initial displacements, that means when t equals 0, s is equal to 40. Find an expression of s in terms of t. So now s is going to be the integral and when t equals 0, s is equal to 40, which implies that 40 is equal to c. So now we can write an expression that s is equal to 50t minus 5t squared plus 40. And we can also tell with our displacement question, like in this one, when I look at the question, I can see that it was probably based on an object falling. Okay? Does that say that in the moving body? It's a moving body, but I can see that that moving body is not being projected by a motor or something. It's probably been thrown through the air. Do you know how you can see from your displacement formula that this is an equation that's affected by gravity? The acceleration of 10 is really close to 9.8. And anytime you get an acceleration of negative 9.8, or negative 10 is rounded, it'll always appear in your displacement formula as a negative 5 in front of whatever variable is being squared. Because when we do the derivative from the negative 5, you're going to get in your velocity the negative 10, and then when you do the derivative of that, you're going to get your acceleration to be negative 9.8. So you'll see that particle moves such that acceleration at time t seconds is given by, did we do this one too? Did you do this one as well? Yes? Okay, good. Time t. So we want the velocity, so you did the integral 2t minus 4 dt t squared minus 4t plus c. We know when time is 0, velocity is 3. So you get, plug in 0 for t, and you get c is equal to 3. So now we can write our velocity is t squared minus 4t plus 3. Yes?
Since we are at time 0, what we then just
All right, so our displacement will be the integral. Was it plus 4t plus 3? Yes? Good. No, minus 4t. And then our integral here will be t cubed divided by 3 minus 4t squared divided by 2 plus 3t plus d. And yes, because we know the displacement at time 0 was 2, we can say that we know that d is equal to 2 when we plug in 0 for t and 2 for s. And then we've got simplify this right away. Plus 2. What does it mean if the particle is at rest? Velocity is 0. So now when we go to our equations, we would go to our velocity equation. We would set it equal to 0. And we can factor it t minus 3, t minus 1. So at t equals 3 seconds and t equals 1 second, our function is at rest. Finally, the displacement of the particle at these times. So all you're going to do is plug in t equals 1 and plug in t equals 3 into our function for s, which was 1 cubed divided by 3 minus 2 times 1 squared plus 3 times 1 plus 2. And on this side, 3 cubed divided by 3 minus 2 times 3 squared plus 3 times 1 here, 3 times 3 plus 2. And what values did you guys come up with here?
I got 3.333.
3.33. Okay. And on this side? 30 over 3? 130 over 3? No. You got 2? 2? Well, I mean, if you simplify 130 over 3. Yeah, I mean, 130 divided by 3, cancel out those, you're left with a 1. Perfect. It works out. There's always a way. And these are meters. That's where we're going to stop for today.